Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a very challenging question involving exponentials and factorials, where a to the power of b plus b to the power of a is equal to a into b factorial. And we have to find out a plus b is equal to how much if a and b are greater than 0. They are positive real numbers. Now, it's a very good example to find out whether any integers will be available. If integers are not available, then are there any factors or any rational numbers available for a and b, where if integers are not available for a and b, then we have to invoke the gamma function here to find out the factorial of a non-integer number, like factorial of 0.5, factorial of 1.5, factorial of 1.6, 1.7, like this. Any number which is rational or irrational, to find the factorial of it, we have to use the gamma function, where gamma n plus 1 is equal to factorial n. We will use this rule and find out factorial a and b if a and b are not integers. First we have to check if any integer values of a and b will satisfy this equation a to the power of b plus b to the power of a is equal to a into b factorial, total factorial. Then we will find a and b. Only one question, two variables, only one equation, two variables, and also we have to find out whether integer values are available for a and b to satisfy this equation, or non-integer values like irrational or rational numbers. Let us try to solve it. In case of irrational or rational numbers, we have to go for the gamma function. Let's go for. Regarding gamma function, in the last 3-4 classes, 3-4 lectures, I have explained what is the definition of a gamma function and what are the different properties of the gamma function, how it can be used for finding out the factorials of factors. Like factorials of 1.6, 1.7, it can be any number, any real number factorial. That can be found out from gamma function. And gamma function definitions are also given, and gamma function n plus 1 is equivalent to factorial n. Now, let us proceed further for solving this question. What is the question given here? Find a plus b when a to the power of b plus b to the power of a is equal to ab factorial and ab are greater than 0. Now, we will go for the solution. What is the given condition? Let us say a to the power of b plus b to the power of a is equal to ab factorial, ab greater than 0. That means we cannot take 0 value for a and b. Now, let us check for the integers. What is the integer value? A greater than 0, that will be a is equal to 1. Then b can be 1, 2, 3. Now, let us say, what is the left hand side? a to the power of b plus b to the power of a, that is 1 to the power of 1 plus 1 to the power of 1, that is equal to 1 plus 1, that is equal to 2. What is right hand side? Right hand side is equal to ab factorial, that is equal to 1 into 1 factorial, that is equal to 1. It implies left hand side is not equal to right hand side. Now, let us try for a is equal to 1 and b is equal to 2. This implies left hand side is equal to 1 square plus 2 to the power of 1, that is equal to 3. Right hand side is equal to 1 into 2 factorial, that is equal to. That means left hand side is not equal to right hand side. When a is equal to 1, b is equal to 3. Here left hand side is less than right hand side. When a is equal to 1, b is equal to 3. What happens? Left hand side is equal to 1 to the power of 3 plus 3 to the power of 1, that is equal to 4. Right hand side is equal to 1 into 3 factorial, that is equal to 6. Here left hand side, in this case here it is 4 and 6, left hand side is less than right hand side. Here in the case of 1 and 1, the left hand side is equal to 2 and right hand side is equal to 1, left hand side is less than right hand side. No, left hand side is greater than right hand side. That means when a is equal to 1, for integer values, when a is equal to 1, b is equal to 1, left hand side is greater than right hand side. When a is equal to 1, b is equal to 2, left hand side is less than right hand side. That implies, and for other values, as a is equal to 1, the other values, it is not equal. That means for integer values, let us say a is equal to, let us try for a is equal to. A is equal to and b is equal to 1. The same as above. A is equal to 3, b is equal to 1. The same as above. That means a is equal to, b is equal to, that also implies left hand side is equal to a to the power of b plus b to the power of a is equal to 2 square plus 2 square, that is equal to 8, and ab factorial is equal to 2 into 2 factorial, that is equal to 1 into 2 into 3 into 4, that is 24. That means right hand side is exponentially increasing as the values of a and b increase, because it is a factor. Hence, there is no integer solution. Now, let's try for other real solutions, real number solutions. Let us try for this. For example, a is equal to 1. What is the value of b? If a is equal to 1, what will be the value of b? How can we find out? A to the power of b plus b to the power of a is equal to ab factorial. When a is equal to 1, that will be 1 to the power of b plus b to the power of 1 is equal to 1 into b factorial. That implies 1 plus b is equal to b factorial. Just imagine, in the last class, in the last lecture, I have solved one example problem, that is solution for 1 plus x is equal to factorial x, which is similar to 1 plus b is equal to factorial b. B is equal to how much? If you call, please see my lecture. Last lecture, and see what is the value of x. We have found that value of x as here in that lecture, x is equal to 2.56. Similarly, what will be the value of b? B will be 2.56. That means if a is equal to 1, b is equal to 2.56. That is the solution. Similarly, for a is equal to 2, you will get some other value of b. B is equal to how much? You treat it as a homework. This we have got from the gamma function property. Gamma 3.5 is equal to, gamma n plus 1 is equal to factorial n. By using that property, we got the value of b as 2.56, and if a is equal to, b is equal to how much? You do it as a homework. Use this property, and for different values of a, you will get different values of b. When we are not restricting ourselves to the integers, because there is no integer solution. Hence, this particular question has infinite solutions for a and b such that a to the power of b plus b to the power of a is equal to ab factorial. This is the answer. That means you can give any value of a. For example, if you go for a is equal to b, let us go. A is equal to b. Let us say, what happens? A to the power of a, because b I am replacing with a. In single, what you call, I am writing that equation in single variable. A to the power of a plus a to the power of a is equal to a into a factorial. That means 2 into a to the power of a is equal to a square factorial. Definitely, we will have a solution for it. We will have a solution for it, definitely. What is that solution? If a is equal to b, if a is equal to b, the solution is, that implies this will have a solution. A is equal to approximately, it will be equal to 1.67. These things, by doing arithmetic, I am explaining the concept. Now you just see how it can be written as 2 into a to the power of a is equal to a square factorial. This can be written as in gamma functions 2 into a to the power of a is equal to gamma a square plus 1. You can easily solve this using trial and error method. And arrive at the value a is equal to 1.67. Approximately. I am not telling it is exact. A is equal to b approximately 1.67. This is another solution. That means for different values of a, different values of b we will get. If a is equal to 1, b is equal to something like 2.56. If a is equal to 1.67, we get a b value as 1.67. If a is equal to, we will get some other value of b. That means it has a infinite number of solutions, provided we define the factorials of a factor. That definition comes from gamma function. With this, I want to conclude this lecture, and thank you for listening to me. Thank you for viewing my lecture. Best of luck to everybody. If you feel there is a value addition to your knowledge because of this lecture, kindly share and subscribe to my channel Maths and Science by IITian. Thank you for listening to me. Best of luck.